Hi, this is Mr. Phillips, and I'd like to talk to you about our practice CER, which is going to be in regards to kinetic energy and speed. Remember when we talked about kinetic energy, we said that there are two factors that determine the amount of kinetic energy an object has. That is the mass of the object and the speed of the object. Those two factors together will determine how much energy and motion there is, or how much kinetic energy there is. Now remember, even though this is a practice writing to get us ready for the actual summative assessment, we need to use our JYMS conventions checklist to make sure that we're doing a quality formal writing. A CER is a formal writing, so you have to make sure you do things correctly. And the JYMS conventions checklist is right here for you, so I'll let you read through that on your own. Now, our challenge for this particular CER practice is to make a claim about the relationship between kinetic energy and speed using the provided data. So we look down here. This is our data table. This should look a lot like a lab that we did earlier. So we're looking at the relationship between kinetic energy and speed. Now, we have to keep some constants here. So the constants that we kept was the mass of the can and the height from which we dropped the can. So the mass of the can dropped and tossed each time was 425 grams. The can was dropped or tossed from a height of 30 centimeters as measured from the bottom of the can. So we kept those as constants. And then we had some independent variables and dependent variables. Our independent variable here is whether we drop the can or threw/toss the can down, so the speed of the can. The dependent variable is the change that we affected, which is how much squish there was. 5 millimeters of squish for the slow drop of the can, and 10 millimeters of squish for the fast moving can. So again, I like to take the claim statement down here and put it right next to my claim so I know what I'm writing towards. So it says make a claim about the relationship between kinetic energy and speed using the provided data. So if I look at my data, I'm going to say, well, it looks like the kinetic energy increases as the speed increases. Based on the slow was 5 millimeters squish, the fast was 10 millimeters of squish. So my claim statement is, the kinetic energy of an object increases as the speed increases as long as the mass remains constant. Remember, if we change both variables, we don't know which one's affecting the amount of squish for the Play-Doh. So now for my evidence, I start that out by restating my claim. So again, I just take my claim from above and I literally am going to copy and paste it into my evidence, and I'm going to copy and paste it into my reasoning statement twice. So that way I have it there ready for me when I get there. So, the kinetic energy of an object increases as the speed increases as long as the mass remains constant. That is my claim one more time. So what I need to do now is I need to try to come up with 3 pieces of evidence, ideally, to support my claim. So what I came up with was the following statements. The data table shows that the speed of the can increased from dropping to throwing, the amount of squish increased from 5 millimeters to 10 millimeters respectively, indicating a 5 millimeter change when the can was thrown as compared to being dropped. And if I look above at my data table, sure enough, the slow was 5 millimeters, the fast was a 10 millimeter change, so that means the difference between the two was 5 millimeters. The increase in squish was due to an increase of speed and kinetic energy due to throwing the can as compared to dropping the can. Remember, the two variables that determine the amount of kinetic energy an object has is obviously it has to be moving because that kinetic energy of motion, but it's the mass and the speed. The mass remained constant. And so my last statement is stating that the mass was constant because the same 425 gram can was dropped or thrown from a height of 30 centimeters. So the mass was not a factor in the amount of squish. So I've come up with 3 statements that help to support my claim. So now I need to go through my scientific principles, and I can either strike through the scientific principles I don't want or don't need, or I can highlight the ones that I do want or the one that I need. Okay? So scientific principle number 1, any moving object has kinetic energy. That is true, so I'm going to leave that for a moment. Number 2, an object's kinetic energy increases as its speed and or its mass increases as long as the other factor remains constant. That sounds like a good one. So if I'm going to highlight something, that would be a good one to highlight. Number 3, any elevated object has gravitational energy. Okay, now that one doesn't do me any good, so I'm just going to strike through that one. because I can see that that one's not going to help me with what I'm trying to do. All right. An object's gravitational energy, again, I don't care about gravitational energy in this, so I'm going to get rid of that one. That does me no good. And energy can be converted or transformed from one type to another. Again, a truthful statement, but it does me no good in this particular claim for this CER. So I'm going to get rid of that one. Now I have to go back up to these two. Number one is a good claim, or I'm sorry, a good scientific principle, but it's also implied in scientific principle number two. So there's really no need for me to have scientific principle number one in here because it's implied and inferred by the information provided in principle number two. So this one right here is definitely my winner. So if I really want to highlight this, I could go up here to my highlight color and pick a color here, and I could highlight that one. Okay, but I don't need to really highlight it if I struck through the others, so it doesn't really matter. All right, so I've got my evidence, I've got my claim, and now I have my scientific principle. So my reasoning statement, I just need to copy and paste the material from above and put it into the right order. So again, I start out with my claim. So my claim says, the kinetic energy of an object increases as the speed increases as long as the mass remains constant. So I just changed it up a little bit, but that's okay. All right, so I'm good. That's my claim, and I just copied it from above, and I'm set. The next thing I need to do is I need to tie in the proper scientific principle to the claim and the evidence. So again, I did not retype all of this. I just went up here and copied and pasted it. So I went up here and copied and pasted it. So if you don't highlight it, then you don't have to have it highlighted down below. So when I originally wrote this, I did not highlight it above either. But when I restate this, notice I have to have the scientific principle number, and I have to restate the scientific principle so my reader knows exactly what I'm talking about. So I restate it by simply saying SP2, scientific principle number 2 up above, states that an object's kinetic energy increases as its speed and or its mass increases as long as the other constant remains constant. Okay? It should really say the other factor remains constant. So I have a typo there, so I should fix that. So again, you want to proofread your material. So it should say as long as the other factor remains constant. Now, my evidence, I literally copied this from above, and instead of having 3 separate pieces, since it's all going to the same claim and the same scientific principle, I just made it look like a nice little paragraph here. And I don't have any typos as far as spelling goes and things like that. All the capital letters should be capitalized, and they are. I have my numbers labeled, so I have 5 millimeters, 30 centimeters. I suppose I could go like this. That would look better on there. I have my grams on there. So again, I'm proofreading this as I go to make sure I have everything right. Now, if I don't have this exactly right up here, like I have a space up here, I can go back and change that too. So that way it looks good the way it should. Okay. So I've proofread it. I've got my therefore statement, which is again, just literally the word therefore, comma, and a rehashing of my claim. So I have therefore, the kinetic energy of an object increases as the speed increases, as long as the mass remains constant. Now, let's go back up to scientific principle number 1. If I had wanted, I could have used scientific principle number 1 and written extra stuff. So any moving object has kinetic energy. It's true we are talking about kinetic energy. However, again, scientific principle number 2 includes this in that statement. So I really don't need to use scientific principle number 1. So remember, that's the stuff that I call purple fluff. You can use it if you want, but you don't have to. It will not enhance your score, but if you use it incorrectly, it could decrease your score. So you want to be careful with the purple fluff part. But I said on here, I could have tied in SP1, any moving object has kinetic energy, due to the fact that the objects in the experiment are moving. So the cans were falling. The cans are falling at different speeds, which gives them differing amounts of KE. But the fact that they have KE is inferred in SP2, meaning SP1 was not needed. So that's why it's purple fluff. Again, there's no point in writing extra material if you don't need to. Stick to the point. All right, so that is our practice CER. So you should be able to complete your practice CER and then show it to your teacher when you're done. Thank you.